Okay, if you look at on this example, it mentioned that the matrix A is the coefficient matrix of homogeneous system. So means that our matrix will be in this form, right, to represent the homogeneous system. So we are required to find the value of alpha and beta so that the system has one parameter solution and two parameter solutions. So in this case, you must be able to differentiate when the system will be one parameter solution and two parameter solution. So when we are dealing with this kind of question, you need to know that one parameter solution is where when the system has one free variables. Okay, while for one parameter solution is when the system has only one free variable. Okay, while for two parameter solution is where the system has two free variables. Right? So before you proceed with this two question, you need to simplify the matrix so that it is in simplified form. So we need to use elementary row operation, okay, for that system. Right, so we know that this is homogeneous system, okay, where the last column you can ignore because it is always 0. Okay, so how we know that our system will be simplified? You need to make sure that these three area to be 0. Right, so that is our main concern here. So we use elementary row operation. And then the next RO will be R3 minus R2, and we put it in R3. Right. So we can see here that this three area is already become 0, so means that it is in simplified form. Then we can stop our RO. Okay, so from here you are able to answer the question. So for the number 1, for one parameter solution, so if you look at on this, when the system will has a one parameter solution, right, where we want only one free variable, right, so that is the case when the alpha is not equal to 0 and the beta is not, the beta minus 2 is not equal to 0, where beta is not equal to 2, right? So when you try to plot in this this solution, okay, in the last row, so you will get an alpha is not equal to 0. So let's say you make it alpha equal to 1 and beta is not equal to 2, then you also can make it 1. Okay, we try to plot in the values. Okay, so when you have this solution, so this will be leading 1 and we will get leading 1 here, right, later on when you reduce this matrix one more. Okay, So at the end, you can see that we have only one free variable here. So it satisfies the condition of one parameter solution. Okay, while for two parameter solution, right, for two parameter solution, so the value of alpha must not equal to 0 and beta minus 2 must be equal to 0, right? Equal to, this one is equal to 2, right? Also, when you substitute the value of beta equal to 2, so you can see that you have 0 and 0 here. So means that two columns, we don't have leading one for two columns, so that is where we have a two parameter solution.